This video is about how to identify asymptotes, particularly from the equation or from the graph of an exponential. And right here you can see a couple examples of exponentials. The first one is an equation, y equals negative 2 to the power of x minus 5. Of course, what makes it an exponential is that there's an x in the exponent. And the graph next to it is also an exponential, and I can tell that just because of the shape, the fact that it kind of looks like a plane taking off. It could also look like a plane landing where it's kind of flat and then it takes off up into the air, or it comes down and then it lands on something flat. The flat thing is an asymptote. An asymptote is a place, an invisible barrier, a line where a graph or an equation gets closer and closer and closer to it, but it never quite hits it, even though it kind of looks like it does sometimes. So let's look at this simple example right here. This is also an exponential. Y equals 3 to the power of x plus 2. It's an exponential because of the power of x, of course. Now you could graph this on your calculator or you could take a look at it, but personally I look at that and I know it's an exponential and I know what y equals 3 to the x looks like. It's like many other exponentials. I'm just going to sketch a graph really quickly here. This is y equals 3 to the x. It has this sort of a shape to it. This should probably be in your parent graph toolkit. Under y equals 2 to the x, they're very similar. It's just that 3 to the x increases a little bit more quickly. Now the only change with this one is the plus 2. And how that changes the graph is it moves it up 2. So here's a graph of y equals 3 to the x plus 2. Exactly the same graph, it's just been moved up 2. And the asymptote is this dotted line that I'm drawing in right there. Normally it would be at y equals 0, but it's been moved up 2. So for this one, the asymptote is at y equals 2. You always write an asymptote as a line. This is a flat line, slope of 0, and a y-intercept of 2. Next one. This is a little bit less simple here. There's a lot more going on. So we have y equals 3 times 0.2 to the power of x minus 4, also an exponential. Now, the first part of it, the 3, that makes it increase. That's the a value. It makes it increase 3 times as fast as it normally would. The 0.2 means every time it multiplies by 0.2. So if I just look at the underlined black portion, like if I type that in without the minus 4, this is a sketch of what it would look like on my calculator. It'd be a little bit taller than normal, but it would multiply by 0.2 each time. So it'd be kind of like a plane landing where it's getting closer and closer to the x-axis, or y equals 0. Now the minus 4 off to the side, what does that do to this graph? Well, it takes that and it moves it down 4. So here's the graph of the whole thing. And you could also verify this on your graphing calculator. It'll look something like this, where the asymptote, the invisible barrier that it gets closer and closer and closer to it, but never quite hits, is that dotted line. I know I drew that a little bit crookedly there, but you get the idea. It should be flat and it should be at y equals negative 4. Hopefully you're seeing this is pretty easy. If you know what you're doing here, you can kind of ignore the rest of the equation and just look at the k value. For this one, it's negative 4, so it's y equals negative 4. Go ahead and pause the video and try these on your own. All right, let's go ahead and see how you did. For the previous one, the first one, going back, looking at it, it says y equals 1/2 to the power of x. So there's no a value, or the a value is 1, so it's normal. It multiplies by 1/2 every time, which means it cuts in half every time. And there's no k value out here. Well, what could I put out here and not change the equation at all? Could have a plus 0. Basically, it's not higher or lower than the normal, the parent graph that you have in your parent graph toolkit. So the first one is y equals 0 because it's just as normal. Hopefully you're also noticing that it's always y equals for exponentials because they're flat lines. All right, the next one. That one you should have y equals -3. And for the next one, we have an a value of 5, so it starts at 5 and it multiplies by 3 every time. But again, there is no k value, or another way to say that is it's like it's plus 0. So for the third one, that should be another one that's y equals 0. And for the fourth one, starts at 0.4 and multiplies by 2 every time. And the asymptote is at y equals 17. So hopefully this short video has given you enough to be able to identify the equation of an asymptote. For a graph, which we don't have any of these, what you want to do is you want to look at it and see where it's landing. It'll always be a flat line, like this is it right here. And I think that's a bit easier, like for this one it would be y equals 2. If you need help with that, you can look at something else on the internet or you can ask me during class. So see if you can do this on your own now. If you can, great, you're ready for the quiz. If not, you can watch the video again or work on it in some other way.